What's up, guys? My name is Cherno. Welcome back to another live stream. Welcome back to another episode of the Game Engine series. Who is excited to be back? This guy, my favorite series. I don't know why I'm so excited. Let's dive into the code straight away, and let's basically, I think today we're going to mark off the last thing we have to do in the C# scripting engine for now, right? Like literally, which is pretty amazing because I did not, like, it kind of flew by. It was supposed to be this difficult thing, but we just got through it really quickly. I know there's still like some minor stuff we will need to do, but this is like the kind of what I like to call the minimum viable product, MVP, right? Like the first kind of vertical slice, all of these corporate buzzwords of what actually needs to be done. So basically, if we take a look at Hazel, what is this, hazelengine.com/roadmap, then we're up to C# fields over here in the scripting. Well, I don't know why it's called C#. Like this is just, I don't know why it's called C# fields because it's a lot more than fields, but basically this is like our C# to do, I'll call it. And this roadmap is accessible by all of you guys. Just go to hazelengine.com/roadmap and you'll see where we're at. So we basically did pausing scene last time. The episode before that, we did the reloading C# assemblies, debugging. That's like the last thing that we need to do. And then we're done. Like after that, the engine, the C# kind of scripting engine is basically usable and we can make stuff with it, which is pretty like amazing. And so what we're going to do next, I think, is probably move on to like first game. And this will tie in with scripting a lot because the whole point of us making a little game in Hazel is going to be to fill in all of the blanks, basically. Fill in the gaps for like all the features as well as the actual C# API itself. Rather than just sitting down and going through like the C# API and trying to just come up with everything possible that we might want to call, you know, from C# into C++ and fill in the API that way, as well as maybe build up a bit of a C# library. It's a much better idea. You know me, I like to do things kind of almost in reverse. I like to start using the APIs if it exists and then just implement it. That's usually how I like to roll. It's a good way to get things done because you know exactly what you need and what the end result should look like, and you can kind of work backwards, you know, and meet from both ends and kind of make everything work. So basically that's the idea. Do you plan on uploading the YouTube video? Yeah, I'm a little behind on the YouTube episodes. I've got them all saved. I just need to like edit them, trim them down, export them, which takes like a bit of time because they're so long, and then I'll upload it. So yeah. Okay, so anyway, back to this though. Yeah, and then the game's going to be a way for us to basically actually implement the C# API, because this kind of scripting thing is not necessarily implementing every single function call that we have in C++ in C# so that we can call it. It's more about kind of implementing the actual infrastructure and getting the actual scripting engine up and running so that we could do that. Okay, cool. So let's talk about debugging. Because that's really, like, as I mentioned, the last piece of the puzzle here. So the way debugging is going to work is like, it should be pretty easy. So let's talk about first of all what it actually means to be able to debug and what the expected result is, what we're actually trying to implement here. So I'm going to open up a sandbox, which is like our little like test game solution over here. And so basically what debugging, what I mean when I say debugging is I'd like to be able to run Hazelnut, which is our editor. I thought I compiled, oh right, I updated Visual Studio, so it's gonna have to recompile everything, of course, because the compiler's changed. Okay, so I want to be able to just hit play here. My scene starts playing, and then I want to be able to go back into like the actual script and like put breakpoints down and actually be able to like, you know, hit them, which of course will pause the running kind of game. And I should be able to like inspect variables. Like literally I should be able to do exactly the same thing that I can do like in C++. Like if I just hit a breakpoint here, I want to be able to kind of go through everything line by line and like, you know, look at variables and debug, right? That's kind of the whole point of that feature. So that's basically what I want to get done today. Now, there's kind of two ways to get, like there's two phases to this. There's basically the kind of C++ mono runtime side of things, which is kind of easy, right? Because if you take a look at the scripting engine, all we really need to do from our kind of scripting engine, because we're hosting the C# runtime, right? So all of the C#, like the whole C# universe is actually existing from within Hazel. And so of course, if we want to be able to let debuggers connect and like, you know, do all of that stuff, then we obviously need to we obviously need to be able to kind of let the runtime that we've created ourselves here know about that and configure it properly. So that's kind of the Hazel side of things. But then we also need like some kind of way to actually connect to that like debugger and I guess to that debuggable kind of application and use it and kind of, you know, interface with it, I guess is what I'm trying to say. And for that, life is actually pretty easy because we have something from Big Hazel that we can use for that, and that is a Visual Studio extension that Peter made as part of Hazel's scripting engine, and we can actually use that for both the game engine series, like Hazel 2D, as well as Hazel 3D or the Big Hazel, which is actually really useful. So if you guys want to get the extension, and you'll need to obviously if you want to actually debug here, then you'll basically have to just go, if you just go into like extensions and then online, so I just went extensions, manage extensions from right within it, Visual Studio online. If you just search for Hazel, you should see this Hazel tools pop up, and then you just need to install it basically. If you can't find it in this list, most likely your Visual Studio is not up to date. But also you can just Google it, like Hazel Tools Visual Studio, and then in the marketplace, like you should see it, and you should be able to download and install it. And basically what that extension does is under the debug tab, it does a couple things, but the main thing that we're interested in is it under the debug tab. Let me just get my my little drawing thing up and running. Okay, so under the debug tab, it adds this kind of, under the debug menu option, it adds this like attached to Hazelnut option, which is like Control-Shift F7 as well as a shortcut for that. And what that does is it tries to attach to a running instance of the kind of mono thing, and it tries to attach the debugger to a running, to I guess a running instance of the actual C# runtime. And that will basically do everything for you. You just need to attach, and then you'll be able to kind of debug as long as debugging is enabled and we've configured mono properly, which is what we're going to try and do here today. So basically, if we just go into init mono, usually you want to, like, you don't always want to just do this. The reason being that, like, if we ship a game, obviously we don't want to have debugging enabled at all. So this really should be some kind of configuration setting option, whatever you want to call it. So what I want to do for now, like, we have this assembly reload pending, like we have a bunch of state here. What I kind of want to do is also just make a little boolean called, I don't know, enable debugging, and we'll set that to true for now. And that's just inside script engine data, but again, this should be in some kind of application configuration settings, is kind of the longer term, I guess, home of that configuration data. And then inside init mono, what I want to do is basically, so if debugging is enabled, we want to do a couple things. And I'm just using Hazel, like Big Hazel for reference here. Which patreon.com/Cherno, by the way. You guys can help support the series, support Hazel, and of course all his code will be accessible to you as well. So we need a couple things here. I mean, there's two real functions that we need to call, and that is monojit parse options with our options, which are going to include enabling debugging, and then also the big one, I guess, is mono debug init. And then this takes in, I believe, a mono debug format, which we have debugger, mono, and none, and I guess mono is the one we need to use here. So debugger is deprecated, so basically it's either none or mono, because they had some other, I guess, debugger that no longer is supported. And that's why that's there, because it can get a bit confusing, I guess, because this is a debugger, but mono is the debug format we want. And then for the options that we're going to provide, so these are basically like command line options that we provide, and we're going to basically set them up this way. So let's see. So what does this want? This wants like, yeah, argc, argv. So it's the same kind of, it's literally command line arguments that we would pass in. And so they're going to be, let's just set them up here. We'll say const char arg v. I guess we'll have 2 arguments here. Well, I mean, I don't know if 2 is necessary. Like 2 is how it's set up here for whatever reason, but we'll see. It might not be necessary to do it in exactly the same way. But basically what Peter set up here is debugger agent equals transport equals dt underscore socket. That's the debugger agent, I guess. The address is going to be localhost, so 172.0.0.1. I'm not sure if you can just add localhost. And then there's a port which is actually configurable in Big Hazel, but it's set to 2550 by default, which I'm assuming should be okay. Of course, if that port is in use, you might want to set it to something else, and maybe in that case, I don't know if the extension can respond to that, but that's basically how it's gonna send all of the debugging information across via, I guess, TCP. So we'll say server equals y, because I'm guessing this is this is like the debug server. Suspend equals n. Log level we've got set to 3 here, and then there's also a log file location, which will be log/monodebugger.log. So this is just probably some kind of log that we can just write out to, or that it will write out to if there's a problem or for whatever reason it needs to log. And then there's also another flag that we use called soft breakpoints. So that's basically the setup. And then I guess there's 2 options, and argv is what we pass in here, and that is pretty much it. Now this guy wants, yeah, not a const char. So let's go ahead and cast this to a char double pointer. But otherwise, these are kind of our arguments. And as I mentioned, some of this you probably want to make configurable, because again, like with the port, for example, we've got that as a configuration option. But yeah, oh yeah, lots. Thanks for that. Logs. Okay. Yeah, and then mono debugging it is undefined because the debugging stuff is in a special place. It's in a special header. I don't know exactly. Is it in utils? Metadata. Debug helpers, debug internal. I don't really know exactly where it is. Let's double check what Hazel does. It's just mono debug inside metadata. Okay. That's kind of what I was looking for, but I must have missed it. Ah, there it is. Okay, so we have to include mono metadata, mono debug as well. All right, cool. Yeah, and that's literally it from Mono's side. So this is what happens when we initialize Mono. The other part of this puzzle is also what happens when we actually load the assembly that we'd like to debug. So inside load assembly, well, actually, see, this is the thing, right? So we load a bunch of assemblies, but assemblies, like, in order to debug properly, we need something called a PDB, which is like a program debug database. No. Is it? Well, no, I guess it doesn't stand for that. But basically, it's, yeah, PDB. What does PDB stand for? It's like a debug database. Basically, what it is, is you might have noticed that anytime you build something, and this is both in C#, I guess, and C++, when you build stuff, like if we look at Hazel over here being built, then you might notice that along with an exe file, we always have a, oh no, I was right. This is a program debug database. It's just the PDB got me, because I'm like, wouldn't that be PDDB? But anyway, so what this guy is basically, you'll have one of these for an exe file, and this is basically a debug database of various symbols. So when we kind of look at an exe file, generally what we have there aren't exactly like function names or anything like that. We just have like an address for a function. So if we have like some kind of function that we call, such as load app assembly that we can kind of see over here, you know, we won't physically have the words load app assembly in there and then it tries to find it. What we have instead is some kind of like memory address, right? So we might have like, I don't know, A, D, E. Don't you just love coming up with random numbers? So we might have something like this. Obviously I'm just writing it in hexadecimal and I put the 0x here so it's clear, but we basically have like some kind of memory address and that's what we call. We call this function, right? And that just tells the instruction pointer to jump to that address in memory, because when we launch the exe, everything gets loaded up into our RAM, and then including that, and then we know that we have to jump to like this address or whatever to start executing those instructions, and we've just invented a function. Cool. So that is obviously very useless to us when we're debugging, because when we look at a call stack, we don't want to see addresses. Like, that tells us nothing. Instead, what we want to see are things like functions. And not only do we want to see functions, we want to be able to see like associated, I guess, metadata with functions. So we want to know like what the parameters are and all of that stuff. And so what the debug database is it basically is like a mapping between this and the original name of the function, right? And probably some other data as well. So like load app assembly or whatever, it tells us this, hey, this is that. And so what that means is when we start, like when we connect with a debugger and we actually look at the call stack and all that stuff, we can see exactly what the functions are instead of just seeing addresses. And you may have noticed that sometimes if you don't have a PDB because you haven't built one or whatever, and you look at the call stack, it's just memory addresses and it's completely useless. So that's what we have to do. Now, again, strictly speaking, you don't have to do this, but it obviously will very much help your debugging kind of situation. So basically, what we're gonna do then is we're gonna try and load this guy. And you may have noticed that inside Sandbox, if we just take a look at this for a second, I mean, what does this go? Binaries. So you can see that along with Hazel Script Core, our DLL, and with the Sandbox DLL, there's a PDB. So we just need to basically say that, okay, well, if we have debugging enabled, right, then when we load an assembly, it doesn't really matter what it is. I mean, you could even do this in load mono assembly so that it just does every single assembly, right? Then, I guess let's do it here ultimately, right? So what we'll do is, along with, you know, loading the actual assembly, let's go ahead and try and load the PDB. Let's go and try and find the PDB, I guess, first, because we like, obviously we pass in the path to an assembly, but PDBs usually have the same name, right? So it's just the same as sandbox.dll, but it's sandbox.pdb. So let's go ahead and try to load something with that same name, but with a .pdb file extension, and then we'll see if we can basically load it, right? So the first thing is we need to kind of figure out what the file name is. So I guess let's do this like, I don't know, let's try and do this here. So if enable debugging, and then I guess what I'll do is let's just kind of refactor this path. So we'll say this will be like a PDB path, and this will be, I guess, assembly path. But like, what do I want to do here? I kind of want to change the extension from DLL to PDB. So what would I do? I guess I can just do... Is there a way to just get... I guess there wouldn't be a way to get the path without the extension, right? I want to Google this. C++ file system change extension. Okay, there is. Yeah, I thought there might be something like that. So there's actually something called replace extension. I don't know exactly where it is, and is that in C++ 17? Okay. There it is, replace extension. So we basically give it we'll give it a replacement. So, and that's gonna be what? So if I just do this, let's see if this will work. So if I just do assembly path, wait, what? Oh, so it is a, wait, I'm confused now. Oh, maybe because this is const. No, so that's not a static function, is it? No, it doesn't look like it. No, it's not. I don't think so. Well, actually, maybe, no. What am I doing? Yeah, it's not. I think it's just because it's const, it's not coming up. So let's do std file system path, pdb path equals assembly path. And I guess we have to do replace, or maybe it's not a thing. No, it has to be though. Why is it not coming up? And also it doesn't make sense because it returns, well no, it returns, it seems to return, yeah, it returns a reference to the path, but you don't need that. Oh, I'm still doing that, sorry. Yeah, there you go. Yeah, it's a non-const function, okay. And what, so if we just do we need the dot? I never know if we need the dot or not. But if we just try and do that. Then that's all we need to do. So I guess let's go ahead and log something. So we'll just say core one trying to load PDB PDB path. Let's just run that. And also that will validate our first kind of init mono section of things. All right, chat, while we're building, you know, building always means it's my time, time to talk to chat. But actually, before we do that, no, you know what? Let's do this because this is our data. Like, because it's just not available here. This should kind of be more or less in an application kind of side of things. But no, you know what? Let's do this for now. Load PDB. Let's just, because this is our little utils function. Let's just make a little parameter called load PDB. And we'll set that to false or whatever by default, but if load PDB will do that, and then that means that when we call load mono assembly, we can just pass in that here, okay? Okay, F5. Oops. All right, chat, what's up? T Bishop says, joined the stream 1 minute ago, already learned something new. Good. I'm glad. Thanks. What were you guys saying earlier? Yeah, the source of the extension is available. Vague Lobster pointed that out, which is good. But it's also, if you just go to the extension page, like if you just Google like Hazel Tools Visual Studio, it's got like a bunch of, on the actual marketplace, got a bunch of info as well as like a link to the source over here. Okay, so yeah, I mean that didn't crash or anything, and if we look over here, so yeah, trying to load oh yeah, good. So just replace the extension. That's great. So we have trying to load PDB Hazel Script Core and sandbox.pdb, right? So that's good. So let's actually try and load it now that we've got the right file path. Is the color for building the project the new update? No, there's an extension called VS Color Output. VS Color Output. It's something I used to use like all the time, and then I just didn't install it at one point, so I probably haven't used it for like a few years. But I just remembered about it, and I'm like, yeah, why am I not using that? It's really useful because you can easily see like errors and warnings because they're like, you know, red and yellow. Okay, so I guess like load PDB, we can say if once we've done that, we can just say we should validate to see if that file path actually exists. So we can do path exists. Is that not what it is? That's just file system, isn't it? Yep. PDB path. So if it exists, we'll try and load it. And to do that, we just need to basically read the PDB file data like we did here. We should delete it. And we should probably start using like a buffer class or something. And then we just do mono debug open image from memory. for the image, it's going to be the same image as this, but this is, oh, sorry, not open image, open, oh, no, it is, sorry. It's open image from memory, but it's a debug open image from memory. So that's kind of the image itself. We get open mono image open from data full, and then mono debug open image from memory. Again, same kind of image situation, I guess, but this time it's kind of the debug component, and the raw contents here are going to be, so this is like a mono byte. What is it? Mono byte, const mono byte, and we'll pass in our PDB file data, and then the size is going to be file size. I guess we can reuse this, right? No, let's not. PDB file size. Okay, cool. Almidev, thank you for the Prime sub. Appreciate the support. And what is this? This is an int. So let's do that. Oh. Wait, what? Maybe we don't need to cast that. Okay, cool. Yeah, that like kind of should be it. Obviously, this is the one we want to release. Yeah, I mean, we should have loaded them, so maybe we should just go do like HZ core info or something, loaded PDB, and then maybe the PDB file, PDB path or something, I don't know. It's always good to have, I'll give you guys a bit of a pro tip. It's really good to, yes, thanks. Thanks, Slavovitz. It's really good to log these things, right? So like load it, like specifically like, oh, you're loading a PDB, what is the file path? You know, you're loading a an actual C# assembly, what is the file path? The reason being that there's a lot of like I just know from experience earlier this year, like there's paths get mixed up all the time and stuff happens where you just might accidentally be loading like the wrong file, or why is my path wrong? You know, what is the application configuration, or what is the game that I've built? What is it trying to load? And it's just so nice to be able to look at the log. I mean, that's what it's for, right? It's so nice to be able to look at the log and be like, oh, this is the path. This is what it's trying to load, you know? Especially when you start like concatenating different paths, sometimes things might be relative to the working directory. Sometimes they might be relative to like the project directory or the actual like, you know, game asset directory. And if so, what is the final kind of absolute path that it's actually trying to load, or relative working path? There might be like a lot of kind of path changing and mutation happening. But there might be like certain configurations that are just set wrong, and therefore you can't load the assembly properly. So it's just nice to be able to validate this stuff here. Okay, that's it, and I guess it worked because we didn't get a crash or anything. So, I mean, do we just try to debug now? Like, is that what we do? I mean, we can try, I guess. So, technically speaking, it should work if I hit play. Okay, it doesn't work. Okay, let's see what's up. Oh, whoa. There's quite a lot of stuff going on here. So it didn't work because we tried to invoke a function. Domain debug info not met. Huh. Domain debug info. Maybe this is some kind of configuration thing. I mean, I'm pretty sure that was all we needed to do. And enable debugging obviously is turned on. So we've done this. But specifically, I think it... I mean, I would imagine that it's something to do with the domain. Oh, yes. Sorry, I forgot one thing. I actually forgot to create the domain. So you need to do mono debug domain create. And then I think we just create it from the root domain. So that just creates a debugging domain for the root domain. Yep. Alright, cool. So now that should probably work. Alright, so we definitely don't have any crashes. So now let's try and hit, we'll go to our sandbox binary, right? So this is still running. Let me just, So if we pause this for a second and then let go, something weird happens with physics. Might have to address that at some point. Okay, so let's just hit play again. So if I just go debug and attach to Hazelnut, what will happen? Okay, well, we get a connection error. The target machine actively refused that. So we get a socket exception. All right, interesting. Because it should have 2550. It should have been listening for that. Because see, we told mono 2550, but then this is saying. And where's this coming from? Mono debugger, virtual machine, blah, blah, blah. Weird. Weird. Well, we didn't crash, which is good, but it clearly didn't connect either. and 2550 is also what we told it to use, yeah. Wonder why. Wonder why. Now, let me just see real quick. Yeah, I don't know where that would be. Just wondering whether or not that's actually correct. But I think it is. I think it is. I'm gonna try a couple things. You know what it might be? No. I mean, I don't think so. Let's have a quick look at this. Yeah, because I'm pretty sure that this is all... Like, I've tried to configure this the same way as Big Hazel so that it would be compatible. But it's possible that there's, like, obviously a difference in configuration somewhere. And that might be the problem. I mean, it doesn't really look like there is. But who knows? So what I might do is I might actually look at the source code for the extension just to see how exactly it tries to connect. And I think, yeah, I don't know, because as far as I'm concerned, it should just be based on the port, right? But I'm not sure. So attach hazelnut command. Seems like that might be it. Execute. Okay, so this... What about the... Oh, here it is. Connection port in Hazel Tools package general options. I mean, I think we probably know what that is, right? Hazel Tools package. It's not even in here. What is this thing? Might be somewhere here. No. Yeah. Because the fact is, it's obviously trying to... Yeah, I don't think it matters what anything else is, because that should just work. Yeah. The log file. Yeah, we could look at the log file. We could definitely look at the log file, but I don't think so, because it's from the extension that the problem is happening. Yeah, so I don't know. I don't think so. I mean, I don't even know if it even wrote out a log file. Weird. And I'm sure that this is correct, because obviously the problem here, it's actually saying that it's, ooh, that's a different problem. Huh. That's weird. That took down the actual thing. Sandbox. Yeah. Well, yeah. See, it's. Oh no. Okay. I guess it's not saying anything about port 2550. Oh yeah. No, it is. So no connection could be made because the target machine actively refused 2550. Why? So it's almost like this. It's almost like we're just not running it. I mean, that's what I would expect would happen. Like, if we don't run it, but actively refused, I don't know if that means... Like, if we just don't run it and I try to connect, what happens? Yeah, we get that problem. So it seems like it's not actually starting this. But it clearly is, right? What does parse options do exactly? It just returns void. And then debug in it, and then mono debug domain create. Now we've done that outer mono JIT init, which seems legit. I wonder if we need to set the mono thread. Probably not though, right? And yeah, as far as I can see, that's it. How strange. Everything looks identical to me. The other thing we're not doing is we're not doing mono thread set main to mono thread current, which Don't know why that would have any. I don't know why that would make a difference. Like that, probably for other reasons that we do that. But we can give it a try. And yeah, we're definitely doing this, obviously. Is it starting the server properly? I don't think it's anything to do with the firewall. It's all local host. Like it should be all internal. And also, well, yeah, if we just try it now, we don't have to be running. It should just connect, but it's not. We could try Big Hazel, right? So if I just launch Big Hazel. Thanks, Dommy, for the Prime sub. Appreciate the support. 2 months. I'm gonna try running Big Hazel. And we'll see if that works. Because if that works, the extension might just be broken, but it shouldn't be. So this is what happened. We got a connection error. All right. Okay, so I guess I have to attach something valid though, don't I? Oh. What if it's... No, that can't be right. Alright, so for this is a dichotomy. Let's try and oh, that's annoying. Let's try and open dichotomy. Alright, and let's try and, I guess, Control-Shift-7, connect. Alright, well, I don't see a crash. And if we... Let's go into like, well, yeah, sure, level manager. Put a breakpoint here. Hit play. Yeah, it hits it. So that seems to work. So it definitely works. Like the extension definitely should work. And we're using this. I'm pretty sure the code is basically identical. So it's very weird that it's not working. I mean, maybe I have to build. I mean, I've built it already, it looks like. Clean. Build. But again, I don't think that should matter because the thing is the actual extension can't connect. It's like, it's basically saying that it's not even running. And so that's the other thing, like, does the, but again, the extension just creates, it's not like it looks for a running process and maybe that's different. as far as I know, it just tries to connect to a particular port, right? And if it's not running like this, it will tell you this. But then if you do run Hazelnut, it's supposed to, obviously it's supposed to like start this kind of debugging server. And therefore, since that's running, when I try and connect now, it should connect. However, it doesn't seem to, see? So that's very strange, unless there's more to it than just, hey, connect on this port, please. Is there some sort of... Yeah, so you can see there's Hazel Tools has a little general option section and a connection port is 2550. Which is correct. And it will try only once, which should be fine, obviously. Yeah, I don't know. Yeah, Peter's probably like sleeping. But I wonder, I guess we may have missed something. But I don't think so. I'm fairly confident that I didn't miss anything. Oh, you know what it might be, guys? I just realized I'm such an idiot. Okay, I know what the problem is. Oh man, this is dumb. So, what are we doing here, guys? Monojit parse options. What are we doing here? Monojit init. So clearly these options that we're parsing are for this function call. So we clearly have to do this first. That is so stupid. So let's move this down. Let's do this before we do jit init. And then let's do if debugging, then also create the domain once we actually have created it here. Oh, that is hilarious. Because the thing is, obviously from the errors that we saw, it was pretty clear that it's just not running this server. And why would it not be running the server? Maybe because we haven't told it to when we've actually created the thing. Alright, did that just crash? Like instantly? I think that just crashed on launch. Okay, oh, because no such file or directory. Why? I guess there's just no directory called logs. Well, maybe create it? Nah, whatever. Let's get rid of the logs directory. Where are our logs going? To be completely honest, like where? Because I guess they're not going to logs. Are we not? Maybe we're not logging to files. Because we have a logging directory, but there should, no, yeah, it's not here. Yeah, actually no, hazel.log, here it is. So we just we don't log into a logs directory. Okay, guys. Are you now ready for this to hopefully work? So let's do this. We're not even gonna hit play. We don't need to. From here, we're just gonna go debug attach to Hazelnut, and hopefully it attaches and we don't get an error. And it looks like we don't get an error. So now what we should be able to do is we should be able to put a breakpoint anywhere, such as like over here inside on create. And you can see I haven't even pressed play yet. And then when I press play, it's obviously gonna call this function because it's gonna create the entity, and then we should break there. And we don't. So that doesn't seem to be working. And then also if we try and inside on update, we're also not hitting those breakpoints. So that was a lot of build up for nothing, wasn't it? That's unfortunate. Why not? Now do we have anything in the logs? Okay, we do have some stuff in the logs. Let's just open it here. Because it's being used by, oh, because it's still logging stuff. All right, let's make it stop. Mono debugger. Oh, it's accepted connection on 2020. What does that even mean? Received interrupt. Suspended, resuming VM. Suspending VM. Hazel script runtime, sandbox. Looks like some kind of exceptions, maybe. Huh. Interesting. I mean... yeah. I feel like it should have just worked. Unless there's something else that I did wrong, which is plausible. And I don't think, like, the PDBs aren't going to affect any of this at the moment, as far as I'm concerned. So I'm not really checking that out. Yeah, I don't know. I feel like that should have worked. Maybe we're not building, like, well, I'm sure we probably are. We're building this in release mode, but I don't think that should affect anything. Because it still has, like, all the PDBs and stuff. Like, you can still do that in release mode. And in Big Hazel, we debug in release mode all the time. So I don't know if that would necessarily make a difference. But yeah, we're just not able to actually hit any of these breakpoints, which is unfortunate. And yeah, I don't think there's anything else to do, really. I mean, there are still some, like, there are some differences in how Hazel works in general, but I don't know if that would necessarily break any of this. Like, it doesn't seem like it should. Soft breakpoints. Like, there do seem to be, like, debugging events happening, but I don't know if it's almost like Visual Studio's just not catching them or something. I don't know. But we were connected. So, I'm like, why wouldn't it be? Strange. Yeah, so we know that it's connected. there is there anything else we need? I mean, yeah. No, it shouldn't be that, because that would have done on connection error, and we would have been notified about that, I think, because it does on connection error. Oh, this is inside on connection error. Okay, maybe not. Hazel start info. Hazel start info. What? Working directory though. What is working directory? Is that important? And project. Is that the Visual Studio project? Yeah, I guess so. Because it passes that stuff in. But this is Hazel start info. Oh, okay, so it passes that into mono. Sure. Yeah, I mean, maybe something's wrong with that. Let's try debug for fun. Is that going to build it into the exact same spot? Probably. Okay, that doesn't seem to work. Weird. No, it's not helping. Yeah, I don't know what. So solution events listener, solution directory says the working directory of this guy. Which working directory is not even a thing here, so it'll be inside the start info. Maybe that's important? I don't know. But it looks like I don't know, solution, Hazel tools package. Like, I think that's gonna be, that's not even our thing. Yeah. So Hazel solution events listener. Solution events listener. Yeah, which is like yeah, that's like a Visual Studio thing. Yeah, I don't know. Don't really see anything else it could be. mean, like, the only thing I can think of is, like, there's maybe a difference in mono version or something between the two hazels. And maybe that's why. Like, because, yeah, it's possible that it changed something. Wait, is this a problem, the way we do this? Not that that... Oh, maybe that is important, who knows. Let's try this. Yeah. Let's try moving this somewhere else. Open image from data full. And so, yeah, let's try to do this before we close the image. I mean, I don't know why that wasn't a... That seems like it probably should have been a crash or something, because we tried to do this when that... Unless this never... No, but it did, because we're logging. So that definitely did exist and did try and work. So let's try... I guess let's try attach again. And no, that's still not working. Yeah, I mean, I don't think it's PDB related, because I don't think you need PDBs to debug. Like, they help, but I don't think they're needed. I might be wrong. Like, I don't know how this works internally. Symbol file loaded from memory is not a mono symbol file. Oh. Wait. So is it saying it can't read that? Well, yeah, it's not a mono symbol file, but because Visual Studio built it, but that should be okay, right? Huh. That's an interesting thing. Wait. Oh my gosh, are you kidding me? Okay. I'm loading the wrong thing. Ugh, that sucks. There's been so many little bugs here and there today. Imagine if that's the problem. It is. Alright, so you do need PDBs. Which I guess kind of makes sense, because it's not... I don't know if that's necessarily what we want, but there you go, we're debugging, right? So I can hit continue, and when I go, we really need to change the time step though, and set a limit for it, because otherwise if you pause this infinitely, you'll just jump forward. But we can put breakpoints, we can go F10, we can look at variables, right? Including like member variables. I think we can even like look at camera, which is an entity, and expand it and see like its stuff, as well as, you know, entity ID and its translation. And the cool thing about looking at the translation here is that, how do you think it's getting this translation? Like, this translation is actually coming from C++. So when because if you look at the entity class's translation, it's obviously not a C# variable. Like, if you go to the entity and you look at translation, look, it's actually calling it to C++, so it's just calling that. Vague Lobster with a tier 3 sub. Damn, thank you for the support. 27 months you've been subscribed for. That's crazy. Thank you for the support. Appreciate it. I hope you're also a patron though, because that would be money better spent. But yeah, so there you go. That's it. We can now debug. And so what we can do is we can test that on create thing again. Tier 4 patron. Yeah, makes sense. I need to make more tiers just for you. So if I put something in on create, and then I connect, and then I hit play, there you go, right? So we can do that. We don't have to like necessarily hit play, then connect, then, you know, see what's up. We can just connect immediately, and I think we can just stay connected, right? And then if we're like, oh, we're getting a problem, we want to debug or whatever, we can just slap a breakpoint in at any time, and you can see we can now debug kind of normally as you would, right? So that's debugging. Now, the other really cool thing about debugging though is this. If we're not connected, so I won't be connected here. Let's say we do something like incorrect. So for example, we clearly want to apply a linear impulse here, but let's say we just don't do this, right? So clearly we're going to get a null reference exception because rigid body's null and we're trying to call a function on it. So if we just build this, it's going to reload the assembly. We hit play. Okay, well at the moment it's actually going to like full on take down the editor, which it really shouldn't do. It should just throw that. I don't know why that's a fatal exception. It should just like get out of that function. Oh, I think I might know why. I think it's probably because the way we call it. Let's see if we can fix that real quick. So the way we call it, yeah, when we invoke method, we pass in null for the exception. I don't think that's what we should do though. Let me see if we do it differently in Hazel. Yeah, so we always provide it an exception that we can then handle in some way, right? Usually by just like printing it or whatever. But basically I'm pretty sure what happens is if we do pass in a little exception object, like so, I'm pretty sure that means that it's not going to explode. So let's try that again. And we can obviously, like, that object is going to contain stuff that we can then access if we wanted to, like, log the exception, obviously, and tell the user about it. Yeah, so you can see it doesn't crash anymore. We're actually getting that exception, and you can see that WASD doesn't work, right, at all, because obviously that line of code is throwing an exception. And yeah, like, what will happen is it'll just return from the function, you know, just like a normal try catch. It will kind of return from the function as soon as we hit the line with the exception. But and we could obviously log that. So let's kind of, I guess we should do something like that. You know, we're able to kind of extract you know, exception info. No, actually, let's talk about exceptions maybe next time, because it is a bit of a rabbit hole and I'd like to handle it properly. But we can kind of, you know, get some information about the exception and handle it. But the cool thing with the debugging, though, is what we can actually do. No. S-E-S-R-E-G-A. Nice name. Strange because both times you pass a null pointer. No, this is not a null pointer. So before I passed a null pointer in, now what I'm passing in is the memory address of this object, which is obviously a stack allocated pointer. Like, it's an object. It's like the same thing as if I just had like a, I guess a UN64T or something on the stack, and then I pass that in, right? So that's actually got memory associated with it, and that's where it's going to write out the exception data. So it's like an out parameter. Okay, so yeah, it does kind of look like I did pass in null, but no. All right, so yeah, so we know we have that exception, right? But the cool thing is, if I connect the debugger and then I hit play, check this out. We actually get like a exception and it points out where it is, and we can be like, oh, yeah, that's right. Rigid body's null. No wonder that's happening. Oh, I forgot to do this, right? And then we can like stop this, you know, rebuild this. That just took down the editor, which is great. We'll have to iron out some of the bugs. I think we're probably not letting go of the debug stuff, actually. That might be part of the issue when we reload assemblies. And now you can see WASD does work because we fixed the bug, right? So we're able, it's pretty cool. So we're able to kind of debug and fix problems and everything works, which is pretty cool. So yeah, cool. Yeah, let's quickly see, because when we reload, right, what exactly are we doing? So we do mono-domain unload, and then we reload the assemblies. So I'm wondering if we need to... No, I mean, I don't think so. I don't know if we need to do anything with the debugging. I don't know exactly why that crashed. Yeah, we'll probably have to... Let's just see if we can... Like, if I make a change here... And I reload... Okay, well that worked. Does it have something to do with debugging? If I connect this, hit play... Okay. Let's stop. Bring that back. Control should be... Okay, that crashes it. So it's a very specific sequence of events, and it's to do with garbage collection, it seems. Yeah, garbage collection is going to be a whole thing, and we need to make sure that when we reload stuff, for example, we actually do collect garbage, because we can't have it linger and stuff. So that's something that we'll definitely have to explore in the future. But for now, debugging, it's in. And we're done with our kind of first level of C# stuff. So that's it. Hope you guys enjoyed this stream. Thanks for watching. I'll commit the code so you guys can take a look at it on the scripting branch, and I will see you guys next time. We'll probably have a little bit of a planning episode and discuss what we'll be doing next time as well. So I'll see you guys later. Goodbye.